Good morning, everyone. Welcome back to CIS 101. Today is February 14th, 2019. So you better get your Valentine's Day presents and you better call your significant other and make some nice plans for this evening for perhaps going out for dinner. So what we're going to do now is, now that you're familiar or more familiar with Oracle Apex, is we're going to do a little bit more with actually building tables and doing some casting, where what we're going to do is we're going to take some talk about different data types insofar as like strings, numbers, and dates, and do a little bit more with Oracle Apex. So that's what we're going to do today. So I fully expect that you would start the video or pause it and go along with the examples. Well, let's get started. Now remember the objective of this lesson. What we're going to do is we're going to show you how Oracle casts different data types. Now when we talk about casting, we really talk about going from one data type to another. Now, as we talked about previously, Oracle and most database management systems support three different fundamental data types. They support dates, they support numbers, and they support strings, or in Oracle, we call them varchar or varchar, depending on what your dialect is. So for the remainder of this lesson, we are going to go over a hands-on exercise, and I'm going to demonstrate to you how Oracle handles these different data types. Again, the different data types being numbers, strings, or varchar2, or varchar, depending on your dialect, and dates. So let me sign in. Now I'm going to sign in to my Oracle Apex account, and we're going to build a simple table. And then within that simple table, we're going to build, say, about 3 or 4 different columns. And I'm going to show you how these different columns react to different data types. So if you want to, you can use an existing table that you already have. But in this case, I'm going to use a new one. So let me build a script that's going to build a table for me. So let me go into SQL Workshop, and I will build a new SQL script that will build a brand new table for us. And again, this is just a table that we're going to be using to test our different casting functions on, or our different casting mechanisms on. So let me go and create a new script. So let me scroll over and create a new script. And I'm going to call this guy SC, and I'll say create. And we're going to call this one Cubs. So quite simply, I'm going to say drop table Cubs. And let me recreate the table. Create table Cubs. And I'm going to give this table the 3 different fundamental data types that I just mentioned. So we will say, how about player, player number, if I can spell it right. And the player number will be a number, comma, player name, and this will be varchar 2, and we'll say it could be 20. We'll make it intentionally short. The name you would think would be larger, but for our cases, we're just going to make them pretty small. So if the player number, the player name, how about the salary? And that's a number. And let's see. We got the player number, the player name, the salary, and we will say signed date. This is the date the player signed with our team, and we'll call this guy a date. Okay, and let me save my script by clicking on create, and my script's created. And I don't think I have any problems in there, but let me go back in there and take a look. Okay, so that's what I have here. I have drop table Cubs, create table Cubs. So we have 4 different columns. We have the player number, the player name, the salary, and the sign date. Now, what the objective of this lesson is I'm going to show you how Oracle handles data types, or can convert one data type to the next. And when it does that, it's called casting. C-A-S-T-I-N-G, casting, like a cast on your hand or your arm if you break it. Now, casting refers to the ability to morph data types into other ones. For example, strings into numbers, numbers into strings, stringers, like I'm fishing, strings into dates, and vice versa. So anytime you're converting or you need to convert one data type into the next, we say we are casting it. Now, casting is an important concept in your IT development. It goes well beyond what you're doing here if you're just beginning working with IT systems, either databases or languages. If you're working with languages such as Java, C#, or any other ones, or C++, you're going to have to deal with casting, or VB.NET, any of them. Because in languages, including database scripts like you're writing here, or scripting languages, you're almost always going to have to deal with going from one data type to the next. You think it's intuitive, but there's a lot of steps going on in there. We have what's called implicit casting, I-M-P-L-I-C-I-T, implicit, which means that the database or the language will automatically make that conversion for you from a number to a string to a date to whatever. The permutations are really many there. And we also have what's called explicit casting, C-I-T, explicit. So there's implicit casting, which is the language does it for you, and there's explicit casting, which means that you have to explicitly say this is the data type that I want to make that conversion. Now, different database management systems, and indeed different languages, are different. Like, for example, Java is an explicit casted language, which means if you're trying to put in a string into a number, you have to say via functions, I want to make this into this kind of number. So you have to pass that string to a number. Also, C# is explicitly cast, which means, again, just like Java. Now, languages like Visual Basic.NET, VB.NET, are implicitly cast, which means that the language or the database management system will attempt to make that conversion for you. And if it can, it just does it. It doesn't fail. It doesn't say, do you really want to do this? It just does the conversion for you. So while we're going through this exercise, I'm going to be going through examples of explicit casting. I'm going to show you how Oracle is an implicitly casted language. So we're not going to do much with explicitly casting in this lesson. We're just going to work with implicit casting. So anyway, let's get back to the example. So in this example, I got a Cubs table, and again, I have a player number, which is going to be an integer. You know, your player number is going to be a 1 through 99. There's not going to be a decimal in there. Player name, which I kept short on purpose, and for the player name, you know, we're going to have up to 20 characters. That's a little short. You're going to see why. We also have the salary. The salary is called a real number. Now, there's two different types of numbers. We have integral numbers, which is, again, player number. I mean, you don't go up on the field and there's player 17 and a half or 17.3 or 17.9. It's 17. So when we have a whole number that we deal with, it's called an integral number. We don't deal with decimals. We don't deal with fractions. Certainly, we don't deal with floating points or decimal points, which would be, again, a fraction. We also have salary. Now, salary is going to be a real number because salary probably will have decimals on it. Now, if you make $1 million a year, you probably don't care if you make $1,000,005 a year. But that is a different type of number. When we have anything with a decimal point in it or a fraction, it's basically the same thing. So let's just say you make $10 an hour. That would be an integer. You make $10 an hour. If you made $10.25 an hour, that would be called a real number. So we have two different types of numbers. We have integrals and reals. So if you earn $10.25, that's basically a fraction too. That's like saying you're making so much money plus 1/4 of the next. So when you think of in scripting or in database languages or anything about dealing with numbers in languages, such as here a database script, which is a language, the language is PL SQL, anytime that you have a decimal, you have a fraction too. like a penny is 1/100th of the next dollar. 50 cents is 1/2 of the next dollar. 99 cents is 99% of the next dollar. So decimals and fractions are really the same thing. I'm kind of beating this in the ground a little bit. All right. Now, in addition to those two different numbers, there's also a bunch of different other data types that we can say. For example, a floating point number is longer than a double floating point is larger than a floating point. Now, we're in the beginning stages of this, so I'm not going to go into all the different data types and what's supported in them, because I want you just to get comfortable with this script and comfortable with, implicit casting versus explicit casting. And at some later date, we could go into all the different types of numbers that can be there. But there are different types of numbers. As a matter of fact, in the code review, this probably wouldn't pass. Your peers would look at this and say, well, what kind of number is it? Is it an integer? Is it a long? Is it a floating point? Is it a double floating point? What kind of number is it? But from here, just know that we have numbers. Now, in Oracle, since we're dealing with Oracle here, Oracle is very, 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 very forgiving on what we put into it. Oracle will really bend over backwards and try to deal with whatever you give it and handle it without you really giving it any undue interference. What does that mean? That means that if you pass into it for the number 17, it will accept it because 17 is a number. If you passed in 17.5, Oracle will take it because 17.5 is a number, even though in reality it's a different kind of number, because 17 is a real number, 17 is an integral number, and 17.5 is a real number. But Oracle will say, you know what, if you say it's a number, I'm just going to try to make it a number if I can. So 17.5 would be a number, so Oracle will take it. Now, if you think about that, there's ramifications of it. If you talk about constraints of the table, we probably don't want 17.5 to be a valid value for the number. So in that case, we're not going to do it here. Like I talked about in the peer review, we would look at this and say, well, what kind of number is it? We shouldn't allow a real number here. So we should allow just an integer rather than a real number. But we'll talk about that casting, and we'll talk about that in a second because we're talking about casting here. Now, ditto with salary. And if I put in $1 million, 10000, I guess if we made $1 million, I wouldn't be making this video and you wouldn't be listening to it. But if we made $1 million, Oracle would look at that and say, yeah, $1 million is a salary, so we're just going to put it in. Give me 1 second here, folks. Make sure we're still going there. Good. I got an ominous message that popped up on my screen. Make sure that we're still good here. So if we made $1 million and we try to put $1 million into the salary column, Oracle would take it. And it would say $1 million is a number. We're going to take it as a number. But $1 million, and I'll give you an imaginary extra credit bonus point to get this right, is $1 million an integer or an integral number, or is it a real number? Well, $1 million without a decimal would be an integral or an integer because we're not putting in any decimals. It wouldn't be real. But we're a real number. Like there's such thing as unreal numbers, but there actually is. There's a series of numbers called imaginary numbers, and if we have some time later this semester, we'll have a lecture just on imaginary numbers because it's a fascinating lecture for me at least. So anyway, so we got that. So dates act a little bit differently as far as casting goes. Now, as far as casting goes, Oracle deals with default date ranges or default date formats. So we can only put in so many different ones if we want to put it in as a string. Otherwise, we have to use a toDate function or a toChar function. We'll just work with the toDate function, and we're going to be doing some surfing and making a couple errors as we go. Remember, this is a live class, even though that you're getting the video of it, so it's not really a canned video. Everything's being doing live. There's not any editing done behind the scenes for you. So anyway, so we got this script. So let's run it. We run the script, click run now, like I want to run it later, right? Of course I want to run it now. This drives me crazy. So we should get this. Table review does not exist because when we try to drop the Cubs table, it's not there, and then it says the table's created. So what I'll do now is I'll go to Edit Script, and I'll let you guys take a screenshot at this, because we're going to go into SQL commands now, and we're going to get back to this a little later. A couple things about this, I'm filling in some dead air. Do we have to recreate the table every time we use it? No, we don't. But for the purposes of demonstration and education, we're dropping it and we're recreating it just so we know there's no, the technical term is crap. There's no crap in there. So we're just dropping it and recreating it. Now remember a couple things here. Now this is from looking at some of your exercises here. Remember when you are dealing with this, every single semicolon that you see here is a command. So how many commands do we have here? Well, we have two. We have drop table cubs, and we have the create table. So we got the drop and we got the create. Now remember, again, we use white space just for visual presentation. Again, the technical term is making it look pretty, where we can at least look at a nice left alignment in here and we can see what we're doing. Also remember that we have commas after each column name, but we don't have one after the last one. So if you add something to the end, you'd have to put a comma there after date and then add your column. But we're not going to do that. Don't do that. Why would you want to do that? Okay. So anyway, so we got this. Drop table cubs, create table cubs, all this other good stuff. Make sure, we run it again just to make sure it's there. If you click run once and it works, click it twice to make it work again, right? There we go, table created. Good, 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 good. Okay, so let me take a picture of this. So we got the player number. I'm writing this down. Number, we got the player name. We got the salary. We got the signed date. There we go. All right, so let's get out of here and go into SQL commands. So let me go up, SQL scripts. Let me go up one step until we got SQL commands. Now notice something about our table before I get into writing some commands against it. Think about what we put as far as constraints in there. Now, on purpose, I didn't put any constraints because I don't want us to fall, into ourselves here. I'm protecting us from ourselves here. So what we're doing here is we're going to be working without a table or with a table without any constraints. On purpose, I didn't put a primary key. I didn't put a check constraint. There's no foreign keys. There's no not nulls. None of that. None of that foolishness. What we're going to do is we're just going to focus on casting and how Oracle works with data types. And while we're doing that, we're going to have a lesson on implicit casting versus explicit casting and all the other good stuff. So how about this? Let me type in import into, and we're going to put in the cubs. Values. It doesn't have to be all in caps. As a matter of fact, well, SQL actually probably should be. And first, let's do something that won't break it. We'll put in the player number is number 17. He is Bob. And Bob makes $1 million a year. Probably not a lot for a baseball player, right? And his sign date is 01/17/2018. And I'll kind of hover it there for a second. Now, one thing about these remote classes is one of the advantages is you can always stop the video and see exactly what I'm doing here. So again, remember for this semester, we're going to have a mix of live classes and remote ones, although most of them will be live. Most will be live. All right, anyway, so let's look at their syntax. Import into, whoops, into, supply the name of the table, and then you put in the values. And the values are denoted starting by an open paren and a closed paren. Now we have 17, Bob. He makes $1 million a year, and this is the day he was signed. So let's take a look at what happens here. Now, again, we're going to keep constraints out of the conversation, not just for now, but for the remainder of this lesson, because I'm trying to eliminate all of that and just get down the data typing. Now, when I try to run this import, oh, pardon me, it's my fault. It's insert. I hope you didn't hit enter, right? Because if I get a phone call or text message saying, Bob, I ran your import statement and it didn't work, it's because I meant insert rather than import. You think I would know that by now. Again, it's a walking and chewing gum at the same thing, I suppose. All right, anyway, so as soon as I try to run the SQL statement, what Oracle will do is it will look, and again, we're getting constraints completely out of the conversation. What Oracle will do is it will look at each of the value and it'll match them. First, it'll count them. It'll say, okay, insert into Cubs. Do I have a Cubs table? Yes, I do. How many columns does that Cubs table have? It has 1, 2, 3, 4. And again, it doesn't count my values, but what it does is it does count. It does go to the Cubs table, and it does count how many columns I have in there. And it says, do I have as many values being passed into the Cubs table than columns that exist there? So if the Cubs table has 1, 2, 3, 4 values in it, am I attempting to put 4 values into that table? The answer, yes, I am. So we passed that gate. So now what Oracle says is, do the data types match? So it goes to the Oracle looks at the table and say, okay, what are the data types for those 4 columns? And Oracle comes back, or the section of Oracle that looks at that comes back and says, the first one is a number, the second one is a varchar, the third one is a number, the fourth one is a date. So then Oracle says, good, good, good. Do I have the corresponding data types that are being passed into that table via the insert statement? Okay, so then we look at it and say, okay, we're putting in, or the insert statement is putting in 17, it's putting in Bob, a string, it's putting in, or attempting to insert 100,000 as a number, and it's attempting to put in 01/17/2018 as a date. Now this is an anomaly, because if you take a look at this, it's not necessarily a date. More on that in a second. Let's get something to work, and then we'll work our way out of this. So let me click on Run. And I should get one row inserted. Now I'm not going to prove to you that this worked. We could go in and write a select and get this data out, but it's going to look predictable. It worked, and we don't need to go in there and prove that it's actually working, because it is. So anyway, at this point, we do a couple of things. Well, number one, it works, but let's talk about data typing. This one was easy, was happy path, and I said kind of ignore this for a second. Let's try something else. Let's say I'm going to put in 17.5 for the player number. The player number is 17.5, and I'm going to put in, and the player name is Cadence. Now Cadence makes $9 million a year and 25 cents. We're going to work with dates at the very last, because some of you are raising your hands saying, well, what about this date? It's not exactly a date, it's a string. And you're right, but we'll handle this in a second. So we got this. We're going to try to put in Cadence. Now remember, we have no primary keys, foreign keys, check constraints, none of that. We're dealing with a single table with 0 constraints on it. So when I take this example and I run it, I get 1 row inserted. Again, big deal. But a couple things here. And this has to do with data types and stuff. So I'm going to leave a couple of things open here. But I want you to take a look at some of the things that work that probably shouldn't have. cadence is number 17.5. Now, I don't care what sport you're into. You might not be in any sport, but 17.5 is the number of the player, right? Is this possible? Well, generally, right, in real life, this probably wouldn't be valid. Because, if you look at the back of a player's number, the back of a jersey, soccer, baseball, football, Indy 500, NASCAR, any of those things, you're not going to have a decimal for a number on it. So keep this in mind. I'm going to leave this open-ended here, that when you're working with numbers in any language, Oracle, Java, C#, SQL Server, really, at some point, you have to really be cognitive on what kind of number you're looking for. Because right here, you can look at this and say, well, it's not really number 17. It's 17.5. It's number 17. So there's other options for you to actually use here. You could make this a string if you want, because you could make the argument, if you wanted to, that we're doing no arithmetic or sorting on the jersey. Actually, we are doing sorting on it, so it could be a number. I'm waffling back and forth because sometimes when you choose a data type, sometimes it is a judgment call. I mean, sometimes it could be a string, it could be a number, it depends on how you use it. A good example of that is like your social security number or your driver's license number without the hyphen in it. Let's just say you want to enter your social security number. Mine's 32412122345. It's not it, of course. But you can make the argument that since we're not doing any math with that, it's not necessarily a number. We can treat it as a string. A little more on that later. But anyway, talking about casting again. Remember, our lesson here is casting. And we talked about different types of numbers. In this case, 17.5 is a number. Cadence is a string. $9,000,025 is a number. And we got this date thing. And again, dates are anomalies, so we're going to handle that at the very, very end. But that worked. Let's try something else. Let's just say we're going to say jersey number 20. Notice I got it in single quotes, not double quotes. Then I'll say this is Cassie. And she makes $7 million a year with no change. Do that again. She makes $7 million. And we'll just keep her the same date as well. Insert in the Cubs values 20 Cassie, 70,000. I'll put 70,000 in quotes too. Now notice we're changing data types. We're saying 20 is a string. Cassie is still a string. She makes $70,000 or $700,000. Is that right? Let's make her. Let's see. It doesn't matter what it is as long as we cite it correctly. She's making $700,000 a year. She must just be starting. Wouldn't it be nice that for like a minimum wage? And she started again on the 17th of January, 2018. So we run this, and this works too. Now this goes against what I just told you, that when we're doing the insert statement, Oracle looks for, number one, does the Cubs table exist? Yes. How many values does the Cubs table have in it? And Oracle says it has 1, 2, 3, 4 of them. So then Oracle says, well, how many values are we attempting to put into the Cubs table? And then it responds 1, 2, 3, 4 of them. So we're doing good so far. We're putting in the same number of values into the same number of columns in the table Cubs. The last thing Oracle looks at is, did the data types match? Now this is where this becomes important. So if you fell asleep until now, which most of you have, it's time to wake up, and this is where the most important part is. Notice the data types don't match. In the table, the player num is a number, the player name is a variable character, the salary is a number, and we'll forget about dates for the last part. So just take it on faith. But it worked. Why did it work? Everything I told you said that it shouldn't work because the data types aren't the same. Now this is where casting comes in. C-A-S-T-I-N-G, casting. Like if you're fishing, you have a fishing pole, you're casting with your fishing pole. What Oracle is doing is it is making one data type into another one. it's looking at this and saying, okay, first of all, I got a string, and the string is 20, 20. That is my string. And I'm trying to put this into the table, and the table has the column data type. We're not going to talk about the column name. It doesn't matter. But for the most part, it doesn't. So here, what happens is Oracle says, I'm trying to put the string 20 into the number 20. Now, believe it or not, if you're a Java programmer or a C# or C++ programmer, that's a big deal. That would fail. In your code, if you said I want to put a string into a number, it just would fail. It'll say the data types don't match. But Oracle is implicitly cast, implicit, which means it will make that data type conversion if it can possibly do so. Now again, for you beginners, you're rolling your eyes. You're like, well, what's the big deal? Why can't it just make the string 20 into the number 20? And the answer is, if you're working in computer science and IT, that is a big deal because you have a data type mismatch. The compiler would say, don't do this. Don't do this. Why do you want to do this? Why are you taking a string and putting it into a number? There's got to be a problem there. So what you should do is you should explicitly cast it. Say, okay, I want to make this string into a number. But that's not what Oracle does. Oracle looks at this and says, I will try to cast this. Try means implicit. So Oracle looks at this 20 and says, can I make this 20 into a number? And it can't. So Oracle says this one's okay. And then it goes to this one here, or this second value that we're passing in, and said, all right, we have Cassie. Is Cassie a string? Okay, Cassie's a string. No further action is required. Cassie's good. And then Oracle will say, what is the value of the third parameter passed into the insert statement? And the answer is, well, it's 700,000. And then Oracle says, is it a string or a number? Well, it's a string. Okay, problem again. We're trying to put a string into a number. But Oracle, again, will try to implicitly cast this. Implicitly means it'll try to make the string into a number. So it looks at it and does some further thinking. And it says, Oracle says, can I make 700,000? Can I make 700,000 into a number? And the answer is yes. So it does so, and it just makes it work. More on the states in a second. So Oracle will look at this, and it will work. Now, some of you will look at this and say it shouldn't work. It should automatically bomb. But Oracle, like I said, like a lot of other languages, and what comes to mind is like visualbasic.net, will actually try to do the conversion, and if it can, it'll do it for you. So this will work. So I'll click on Run. And it will actually work before. And it worked again, and don't worry about this 20 being entered twice, because again, it's not a primary key. But let's try a couple other things. How about we say Cassie is number 25, and she makes, how about $70,000 a year? And I'll do this two ways. I'll make 75. I'm doing too much at once here. Let's do the following. Let's have number 21, and this is going to be Kathy. We'll work with T's, with C's. And Kathy makes 700,000. Let's make her make 1,700,000 a year. Again, don't worry about dates. We're doing dates at the very end. Take a look at this. When I click on Run, will this SQL statement fail, or will it succeed? Remember, when the SQL statement fails, no data gets put in, and we get an error message. Ooh, and let me get rid of this guy here. Kathy is 21, number 21, jersey number 21. Her name is Kathy, and she makes $1,700,000 a year. This will fail. And let me show you why. When we use numbers, we can't use any kinds of currency symbols. Now you're looking at this and you're looking at the comma, and you're like, well, that's not a currency symbol. That separates my hundreds from my thousands. And then you look at this and say, well, that's not a currency symbol either, because it separates my hundreds of thousands by my millions. But if you say that, you're speaking at this in a truly American point of view. because it's a currency symbol for the United States. So we look at this and we're like, well, it shouldn't count, but it does. So if I click on run, Oracle says too many values, specifically because I got this comma in here. But let's just say I don't. Let's just say that we have 1,700,000, and I'll get rid of those commas, and we'll put, and give me a second, 30. Look at my timing here. Making sure my timing's still right. Okay, so if I try to run this, I'm going to fail. Oracle is looking at this entire value, and it's got a $sign, 170000, whatever it has on there. It's got that sign on there, and it tries to make that into a number. It tries to cast it. It tries to cast $sign 1,700,000 into a number. And guess what? It can't. It can't cast this because it doesn't know what this $sign is. Now again, you're looking at this from a truly American point of view, and you know what this is, but Oracle doesn't. Oracle just looks at numbers. There's no such thing as a currency data type in Oracle. Now, if you're working with SQL Server or Access and some other database management systems, you will have currency. You will have currency as a data type, and you get to specify what kind of currency you're using. But in this case, you don't. You just have basically your number to work with. So let me get this back out there again. It will not cast that. It doesn't know what it is. All right. So anyway, I click on run, and this should work fine. So let me click on run to show you that it'll work okay. So anyway, and strings are easy because they have to have the single quote around them. You can't have a double quote. If you have this and this, it's not going to work. Remember, you only deal with single quotes when you're writing SQL statements. To show you that this won't run. And you get column not allowed here. When you're using double quote statements, it specifies that you're referring to a column. You might not know what that means, and if you don't, that's fine. For the purposes of this video, you don't need to know that. It's just saying it refers to a different column. All right, so anyway, we have casting. Let's do some other stuff with this. Let's just say we have a real long name. Say Kathy, and we'll put in Von.